See the first question. They have said that A, B, C are the three roots of the equation. Therefore, we can write the sum of all the roots. The sum of the roots taken two together and the product of three roots is. Now, we are squaring both sides of equation 1 because these values will be needed while evaluating the given expression. Now the value of AB plus BC plus CA is 2. So we got A square plus B square plus C square is 1 minus 4, which is actually minus 3. This value will be needed. That is why I have calculated it in beforehand. Right? Now, let me square both sides of the second condition. Now let me take ABC common. Therefore, this value will become 4 minus 2 times ABC. The value of ABC is 3 and A plus B plus C is 1. Therefore, we are getting. So we got. These two values will be needed. That is why I have calculated it beforehand. Okay. Now we have to find out the value of the given expression. Now, what I'm trying to do is, I am not taking the modulus sign. I am simply calculating the given expression. And at last, I will take the modulus sign. We are having the expression like. So let me just multiply this with A. This one with B. And this one with C. And as we got that ABC is 3, we got ABC as 3. Let me replace it. Right? Now let me take LCM. So now let me consider the numerator only. I am simplifying the numerator only. So if I open the brackets, we are going to have okay. So now if I open the brackets, we are going to have this one. Now, let me just replace the values that right now we have got. We have got the values of A square plus B square plus C square is minus 3. ABC is 3. And A square B square plus B square C square plus C square A square is minus 2. Does we get the result as 27 goes off? So it's only minus 12. So the numerator is coming to minus 12. Now let us try to simplify the denominator that we have, which is so this can be written as so let me simply replace those values. A square b square plus b square c square plus c square a square is minus 2. And a square plus b square plus c square is coming to minus 3. So we are having the denominator as 3 only because 27 goes off, right? Therefore, the given expression, this expression becomes with a mod sign minus 12 over 3, that is modulus of minus 4, that is 4. Hence option D is correct. Is it clear? Okay. Now the second question. Now in the left hand side, let me just make a group of sine 6 degree, okay? So I made a group of sine 6 degree, sine 54 degree and sine 66 degree. Why I have done so, I will tell you. Into sine 14, sine 46, sine 74 degree. This is another group. And the third group will be sine 26, sine 34 degree and sine 86 degree, right? Which is equals to 1 over a sine 54 degree. Now, we know a formula, rather I should say a relation, that sine theta sine 60 degree minus theta sine 60 degree plus theta is always equals to 1 over 4 sine 3 theta. This formula or this result I will use here to simplify my given expression. So the left hand side will become sine 6 sine 54 sine 66 degree can be written as 1 over 4 sine 3 theta. Similarly for the second one, 1 by 4 sine 3 theta. Similarly for the third one, 3 into 26 degree. And in the right hand side, we are having 1 by a sine 54 degrees, right? Now, this all cancels. Now we are having sine 18, sine 42, sine 78 degrees, which is equals to 1 over a sine 54 degrees. Again, we are having the same formula we can use here, this relation we can use here, because it is sine theta, sine 60 minus 18 degree, which gives us 42 degree. Sine 60 plus 18 degree gives us sine 78 degree. So we can write this thing as 1 over 4 sine 3 theta, means 3 into 18 degrees. This is sine 54 degrees. 1 over a sine 54 degrees. So comparing, we can get a is 4. We are getting a as 4. Hence, option D is correct. Is it clear? Okay, let us move for the third one. A and B are the maximum and minimum values of the given function. Now, I'm rewriting the function. We have been given now we have to find out the maximum and minimum value of this function, which are represented by A and B respectively. So let us find out the extreme values for this function. So for that, what I'm doing, cos square x can be written as 1 minus sine square x. So we are having now we can write this thing as okay. So let me just separate. So we are having okay. So our fx comes to, let me just make it a sum of two squares. So it will be sine x minus 2 whole square plus 1. Now, to get the maximum value of fx, this expression has to be minimum. If fx is maximum, then the expression which is in the denominator should be minimum. And the minimum value will occur when sin x equals to 1. Therefore, the maximum value, which is denoted by A, is 1 plus 10 over 1 square plus 1. So that gives us 1 plus 10 over 2, that is 6. And this is the maximum value of the given expression. Now, what will be the minimum value of fx? Fx will be minimum when this expression is maximum. And the maximum occurs when sin x comes to minus 1. Therefore, the minimum value of the function fx is, which is your b, is 1 plus 10 over, because minus 1 minus 2 whole square, that gives us 9. 9 plus 1 is 10. So it's 1 plus 10 over 10. That gives us 2. Therefore, the maximum value is 6 and the minimum value is 2. Now, what they have said, their question is, what is the value of 2 times? So, let me just simply put the values. B is 2, A is 6. So, in this case also, the option is D. I hope it is clear to all of you. Let us move for the next problem. We have been said that x minus a into x minus 3 is minus 1. It has all integral roots. Okay, so x has all integral roots. And A, they have also mentioned A belongs to integers. So we have to find out all the possible values of A and the product of all possible values of A. That is, in one word, we have to find out the values of A from this equation, where X will take integral values, A will also take integral values. So when the product of these two equals to -1, there are two cases which can happen. Case 1, when X minus A is 1 and X minus 3 is -1, and case 2 is when X minus A is -1 and X minus 3 is 1. So from case 1, what we are getting? From case 1, we are getting X as 2. So from there, we will get the value of A from the first one. That is, A equals to X minus 1 implies A is 2 minus 1, that is 1. So X can be 2 and A can be 1. This is one option or one solution. And case 2 is X is 4. And from the first one, we can write so the case 2 is X is 4 and A is 5. Is it clear? So the possible values of A are, how many possible values of A are there? 2. So there are 2 possible values. Now what they want is the difference of 3 times the number of possible values of A. 3 times the number of possible values of A, which is 2 in this case, minus the product of all possible values of A. Now, the values of A is 1 and 5. These are the possible values of A. Therefore, the product will be 5. So, our answer in this case will be 1. Hence, option A is correct. Is it clear? Okay. Let us move for the next problem. Next problem, we are having a matrix match. So let me take the first one. Tan 16, tan 42, tan 44. Tan 45 I'm not writing because tan 45 degree is 1, so it will go off. So tan 76 degree. So again we have a relation . Tan theta tan 60 minus theta into tan 60 plus theta is always equals to tan 3 theta. So in this case, if we observe, we will find that tan 16, tan 44 and tan 76, these 3 terms are falling in this category. Okay, so we are having what? Tan 3 into 16 degree into tan 42 degrees. Is it clear to all? So we are having tan 48 degree into tan 42 degree, which can also be written as, because 48 and 42, they are complementary to each other. Tan 90 minus theta is cot theta, so it is cot 48 degree. Tan 48 into cot 48 is 1. Hence, for 1, the matching in column 2 will be S. Okay, let me take the second one. So 1 minus cot pi over 10 into 1 minus cot 3 pi over 20. Now, pi over 10 is 18 degree. And 3 pi over 20 degree is basically cot 27 degree. Now, let me just multiply. So now if we make a bracket, we make a group of and let me just convert everything in terms of sine and cos we are getting. So we are having this is sine A cos B plus cos A sine B. So it will be sine A plus B, which gives us sine 45 degrees. Now, observe one thing. Cos 18 degree, cos 27 degree. How can we write that? Let me just do it here. Cos 18 degree plus 27 degree. This is actually cos 45 degrees, which can be written as so cos 18 cos 27 degree can be written as cos 45 plus sine 18 sine 27 degree, right? Now, if I divide both sides by sine 18 sine 27, so we are having sine 18 sine 27. So in the right hand side we are getting cos 45 plus 1. Is it clear? Now, cos 45 degree is basically 1 over root 2. So 1 over root 2 sine 18 sine 27 plus 1, right? So I will replace this part. I will replace this part by this one. So we are having 2 plus 1 by root 2 sine 18 sine 27 degree minus sine 45 degree is 1 over root 2. Along with that, sine 18 sine 27 is in the denominator, right? So this and this will be cancelled. So we are left with 2. Therefore, the value of the given expression in 2 is nothing but 2. So 2 will be linked with R, right? It will be matched with the option R given. Now let us consider the third part. Now third part is a very interesting one. They have said pi, k is from 1 to 15, sine k pi over 10. Now if you observe carefully, you will find that in place of k, I will put 1, 2, 3, 4 and all are multiplied because pi is there. So it will be like sine pi over 10 into sine 2 pi over 10 into sine 3 pi over 10, and this thing will go on, and the last term will be sine 15 pi over 10, correct? But there is one term in between which is sine 10 pi over 10, isn't it so? Now 10 pi over 10 is basically sine pi, and sine pi is 0. So this whole product will become 0 straight away. No calculation involved in it. Therefore, 3 will be linked with P. Okay, and we are left with the last one, that is number 4 for this column matching type, plus cos 65 cos 55 degree, right? So let me take half common. So it will be 2 cos square 65, 2 cos square 55, 2 cos 65 cos 55, right? Now 2 cos square theta can be written as 1 plus cos 2 theta. Similarly for this one also. and this one is 2 cos A cos B. So cos A plus B. So this is 2 cos 120 degrees minus half. And we are left with cos 130, cos 110 and cos 10 degree. So this thing will give us half 3 over 2 plus this part. Okay. So this will give us. Now let me apply the formula cos C plus cos D for these two terms. We are having 2 cos C plus D by 2 cos C minus D by 2 plus cos 10 degrees there. So this is 2 cos and we all know that cos 120 degrees minus half. So it will be 2 times minus half cos 10 degree plus cos 10 degree. So this 2 and 2 will go off. So it's half minus cos 10 plus cos 10. So this one will give us 3 over 4 because this 2 will be cancelled, right? So your part 4 will be mapped with, it will be mapped with Q. Okay. Now let us move for the next problem. This is our integer type problem. In this question, f of 1x is given mod of mod x minus 2 and the relation which is given is fn x is modulus of fn minus 1x minus 2 for all n greater than equals to 2, n belongs to any natural number. Now they have asked for how many number of real solutions are there for this function. That is, we have to draw the graph of two functions here. One is f suffix 2015x and we have to draw the graph of y equals to 2. Y equals to 2 is basically the line which is parallel to the x-axis and the number of points where it is intersecting the curve will be the number of solutions for this equation, right? Now, to find out f suffix 2015x, how the curve will look like, let me just draw the graph of f1x. We will simply use some graphical transformation. One is y equals to mod x. The graph looks like this. Mod of x minus 2, so it will come down by 2 units along the y-axis. So the curve will look something like this. This is your 0, minus 2. Now, this is the graph of mod x minus 2. Now the graph of mod x minus 2 will look something like this. This point is 0, 2. Now, if 1x equals to 2, if I draw the graph y equals to 2, we can easily see, let me change the color of the pen. Y is equals to 2 is this line. And we can easily see that it is intersecting the curve at 3 points, right? So, if 1x equals to 2, we are having 3 solutions, right? Now, let us use the relation given to find out what is f2x. So, f2x will be modulus of f1x minus 2. Now, f1x is what? Modulus of mod x minus 2 minus 2. Now, the graph of modulus of x minus 2, this one is this graph, right? So, minus 2, again it will come down. This whole graph will come down by 2 units along the y-axis in the negative direction of the y-axis. So, the graph will look something like this. Right? Now, when you are taking, this is the graph of y is equals to modulus of mod x minus 2 minus 2. This is the graph of this. Now, to draw f2x, we have to put a mod sign outside. So now the graph will look something like this. Right? So this is the graph of y equals to f2x. Now, if I draw the line y equals to 2, we can easily see that it is intersecting the curve at 4 points. So, f2x equals to 2, we are having 4 solutions. For f1x, we got 3 solutions. For f1x, we got 3 solutions. For f1x equals to 2, we got 3 solutions. From f2x equals to 2, we got 4 solutions. Now, if you observe this pattern, you will find that when it is f1x, we are having 3 solutions. When it is f2x equals to 2, we are having 4 solutions. So, whatever may be the suffix, the number of solutions will be the suffix plus 2. So, it is 2017 number of solutions you will get when we draw the graph y equals to, when we draw the graph of y is equals to f2015x and y equals to 2. They are going to intersect each other at 2017 points. Hence, the total number of real solutions for this equation is 2017. So, 2017 number of real solutions are possible. So, for this question, the answer will be 2017. That's the answer. Okay. Now, let us move for the last sum of this test. We have been given x square minus x plus 2 equals to 0. We are having 2 roots alpha and beta. So, alpha plus beta is 1 and alpha beta is 2. Now, we have to find out, let me just consider the numerator only first. We have to find out sigma n from 1 to 5 Sn. And your Sn is alpha to the power n plus beta to the power n. So, in this case, we have to find out the value of S4 plus S5, right? This is all about your numerator. I haven't touched yet the denominator. I will do it later on after completing this. So, for S1, if we consider the alpha and we write it in a bracket, so we are going to have alpha, alpha square, alpha cube, alpha 4, alpha 5. Same thing with beta. beta plus beta square plus beta cube plus beta 4 plus beta 5, right? So let us just check what will be the answer for what is the value of this one. Because the answer for alpha will be exactly same for the beta also. Only thing is that here alpha is involved, there beta is involved. Nothing else is given more there. So how to solve this one? Let me take alpha square common from these two. So we are having 1 plus alpha square, and again you are taking alpha cube common. So we are having 1 plus alpha square. I have taken alpha cube common from alpha cube plus alpha to the power 5. So we are having alpha square plus alpha cube into 1 plus alpha square, right? Now if I take alpha square common, we are having 1 plus alpha into 1 plus alpha square. Now since alpha is a root of this equation, hence alpha square minus alpha plus 2 will be equals to 0. And alpha square plus 1 will be alpha minus 1. So I can replace this 1 plus alpha square by alpha minus 1. So we are having what? Alpha plus alpha square into alpha square minus 1. Again, alpha square minus 1, we are having alpha square minus alpha plus 2 is 0. So what is alpha square minus 1? It will be alpha minus 3. So let me just replace that. Alpha square minus 1, I am replacing it by alpha minus 3. And I am replacing alpha square by alpha minus 2. So what you are getting? Alpha plus alpha square minus 5 alpha plus 6. So we are having alpha square minus 4 alpha plus 6. Again, in place of alpha square, if I write alpha square is alpha minus 2, so simply replace that. It's alpha minus 2 minus 4 alpha plus 6, right? I have replaced alpha square by alpha minus 2. That's it. So we are getting minus 3 alpha plus 4. The same thing we will get in case of beta. In that case, we will get minus 3 beta plus 4. For this part, we will get minus 3 beta plus 4. So therefore, if we add these two, we are going to have minus 3 common. So it's alpha plus beta plus 8. And we all know that we have already said that alpha plus beta is 1. Therefore, it will be minus 3 into 1 plus 8. That gives us 5. Right? So for the numerator, we are getting the value 5. Now, for the denominator, we are having sigma n is from 1 to 4, alpha n, beta n plus 7. It means what? It actually means alpha plus alpha square plus alpha cube plus alpha 4. Same thing here, beta plus beta square plus beta cube plus beta 4 plus 7. Now, again from this, what I am doing, from this 2, I am taking alpha common. And from this 2, I am taking alpha square common. Right? So, I am not doing this beta thing because this beta thing will be exactly the same way as I'm doing with the alpha. So whatever answer, whatever simplified version we will get for this alpha will be exactly same for your beta. So I'm not doing beta anymore because it will be a, wastage of time. So whatever beta will be there and plus 7. So it's 1 plus alpha square into alpha plus alpha square plus the same thing with beta, that is 1 plus beta square, beta plus beta square plus 7. Okay. Now, again, alpha square plus 1. Here I have written your alpha square minus alpha plus 2 is 0. Therefore, alpha square plus 1 will be your alpha minus 1. So, let me just replace this with alpha minus 1, and if I take alpha common, we are having alpha plus 1. Same thing with beta, I'm not writing it. So, this is alpha into alpha square minus 1. Again, alpha square minus 1 can be written as minus alpha plus 3, which is 0. Therefore, alpha square minus 1 will be alpha minus 3. So, let me replace that again. Alpha minus 3. Same thing with beta plus 7. So, it's basically alpha square minus 3 alpha plus same thing with beta. It will give us beta square minus 3 beta plus 7. Now, what is alpha square? Again, we can replace this by alpha square is alpha minus 2. So, let me replace that. Alpha minus 2 minus 3 alpha. Same thing here. Beta minus 2 minus 3 beta plus 7. So, we are basically having minus 2 alpha minus 2 beta. This is minus 4. So, plus 3. So, if I take minus 2 common, so it is alpha plus beta plus 3, and alpha plus beta is 1. So, we will write minus 2 into 1 plus 3. So, your answer comes to 1 only, right? So, for the numerator, we are getting 5, and for the denominator, we are getting 1. Therefore, the given value will be, the numerator is 5 and the denominator will be 1. So, the answer will be 5 in this case. Is it clear? So, that is the option for question number 7. I hope you have understood this. So, see you in my next video.